All right, welcome back again. This is acids and bases and salts continued. Okay, so we've already kind of been talking about acids and bases and how corrosive they are and what happens when they react with each other. That's what we're looking at now. Okay, so when we take H2SO4 and sodium hydroxide, or sulfuric acid and sodium hydroxide, we are going to get a salt. A salt is an ionic compound that pretty much takes the H and the OH off of it, and we put the other two things together, we become a salt, and it's sodium sulfate is the salt. Okay, so how does this work? All right, so what is a salt? A salt is a compound made from acids and bases. So they are ionic compounds. It takes the anions and the cations from the acids and bases and puts them together. They are not bases and they are not acids anymore. May or may not be very hazardous. Okay, so some examples is CaCO3, limestone, MgSO4, Epsom salts. You could use these at your thing, and NaCl, which is table salt. But KCN, cyanide, which is very poisonous. Okay, so it can be either or. All right, so but they're both salts in this case. Okay, so we're going to talk about what happens. We've already kind of talked about this in the past when we did our posters of acids and bases, single replacement, double replacement. We had a neutralization reaction with acids and bases. When you take an acid and you mix it with a base, you make a salt and water. Let me repeat that. When you take an acid and a base and you put them together, you make a salt and a water. Acids are very reactive, bases are very reactive, but when you mix them together, they become neutral, which is low reactivity. So again, earlier we said that the acids were more red in tone and the bases were blue. Okay? When you put the red and the blue acids and bases together, these are indicators, by the way, not that they're always red and blue, but when you put an indicator in it, acids turn pink, bases turn blue. When you mix them together and it becomes neutral, you get a green. Okay, which means it's telling us with this indicator that this has got a salt and a water in it. So that's why the colors on our PowerPoint are red and blue, and then we turn green. Okay, because neutral is usually indicated with green. Okay, an acid-base reaction is simply this. We take hydrochloric acid and sodium hydroxide, two corrosive substances. Okay, you don't want to touch hydrochloric acid, you don't want to touch sodium hydroxide. Okay, you put them together, you're going to get a salt and a water. Okay, you're going to get water and table salt. Okay, and water, you can drink it, table salt, you can eat it. So we went from very corrosive and dangerous to very non-corrosive and not dangerous. Okay, that doesn't always happen. That just happens in this one. So you take very, very reactive to not reactive. And what's happening is, if you take a look at the red and the blue, okay, and the green, that's why we kind of did this. The hydrogen and the hydroxide combine together to make HOH, which is water, two H's and an O. What's left over is your anion and your cation, and they come together. But remember, it goes cation, then anion. So your sodium and then your chlorine, which is sodium chloride. It's also considered a double replacement reaction. We're switching partners. Okay, the ions, the positive ions are switching with the positive ions, the negative are switching with the negative. Okay, so here's some more examples. Okay. All right, so balancing an acid-base reaction, pretty simple to the point. We got to make sure they're balanced. Disregarding salts that are acids or base both. Okay, non-reactive means that salt and water does not react with things, like a new car at the beach. Okay, so it doesn't mean it's not harmful. It just means it doesn't react anymore. Okay, all right. I hope you guys enjoyed this. There's one